Hi, welcome to Studym8. My name is Shivaprasad. So we have started December challenge to complete 14 all the 14 chapters of maths in 14 days. So we have completed day 1 with arithmetic progression. So this is day 2. We'll be looking at introduction to trigonometry. So we will look into all the concepts that are given in your textbook, and also we'll solve the previous year question papers that were given in CBSE board in 2025. It includes all the sets in the final exam, and it also includes supplementary and also the question paper for visually impaired candidates. So I feel introduction to trigonometry is a very important chapter with respect to the marks it commands in the board exams, and also I feel it is a very easy topic if you understand it and practice well. Let's see the concepts. So you have studies from earlier classes about lines, angles, triangles. Here in this chapter we are learning about right angled triangle. You know that any triangle has three angles, right? Three sides and also three vertices. Similarly, a right angled triangle also has three angles, three sides and three vertices. Okay. So in a right angled triangle, one of its angle is of 90 degrees. Right, this side is perpendicular to this side, so one of the side is 90 degrees, and because of this the side opposite to that will be the longest side of that triangle, and it's called hypotenuse. Okay, and you have also learned about the ratios in your previous classes, right? So the unique thing about ratio is it doesn't change according to the measurements. Let me give you an example. So this is an Indian national flag, and the measurement of this is always in the ratio of 3:2. So the length and breadth of the flag is always in the ratio of 3:2. If the length is 300 centimeters, the breadth will be 200 centimeters. If the length is 3 meters, the breadth would be 2 meters. So to get the exact dimension of the flag correct, so we just have to maintain the length and breadth in the ratio of 3:2, no matter how small the flag is, how large the flag is. Right? That is the beauty of ratio. And we will use that ratio to find the ratios of the sides of the right angle triangle, and we can use it in so many purposes, right? Let's take this right angled triangle to work out. Let us name the vertices as ABC. So this is the 90-degree angle, right? And the opposite to that would be the longest side, that is called hypotenuse, right? Okay. So apart from the 90-degree angle, we have other two angles, angle C and angle A. Okay. So as the angle changes, the length of the side of the right triangle also changes. So let me demonstrate that to you with an example. So let us say this is also a right angled triangle. So I'll change the angle here, right? So I'm making the angle bigger, and I'll make the angle smaller. So the length depends upon the angle of the triangles. That means the ratio of the length also depends upon the angle of the triangle, right? For the sake of example, let us look at everything from the view of angle A. Okay. So here we have, from A, we have three sides, and with that we can actually draw out three ratios. One would be the side that is opposite to A, opposite to angle A. The other side would be the side that is adjacent, that is just beside A, that is the adjacent side. So BA is the adjacent side with respect to angle A, and CB is the opposite side with respect to angle A, and CA is the hypotenuse. So let us discuss the first three basic ratios. That would be, one would be opposite by hypotenuse. Opposite by hypotenuse. So this ratio is called sine of angle A, or in short sine A. And we have other ratio with adjacent and hypotenuse. The ratio of adjacent by hypotenuse is called cosine of A. Cosine of angle A, in short we write it cos A. So the first one is opposite. Opposite by hypotenuse is sine. So if you do it like this, you will remember opposite divided by hypotenuse is sine. So adjacent by hypotenuse is cos. And the third one is opposite by adjacent. And the name of this ratio is tangent. Tangent of angle A, or in short we call it tan A. So this is the name of the ratio of the side that is opposite to angle A divided by adjacent of angle A. So we have three ratios, sine, cos, tan. By finding the reciprocals of these, we will get another three ratios. So the ratio of side that is opposite divided by hypotenuse was sine A, and we want the reciprocal of it. So that is called cosecant of angle A, or in short we call it cosec A. So reciprocal will be hypotenuse divided by opposite. So this is cosec of A. Similarly, cos A was adjacent divided by hypotenuse, right? So if we reverse it, this was cos A. So the reciprocal of this is hypotenuse divided by the adjacent side. So the ratio of hypotenuse and adjacent side of angle A is secant of A. We call it sec A. And the third one, tangent. Tangent was opposite by adjacent. So this was tan A, and reciprocal of this is adjacent by opposite. So the length of adjacent of angle A divided by the length of the side that is opposite to angle A will give us cotangent. The name of this ratio is cotangent of angle A. In short, we call it cot A. Right? So I guess you guys already know this. The name given to these ratios were trigonometric ratios. So let us do one thing. Let us find the trigonometric ratios in this right angled triangle. So these are trigonometric ratios. So trigonometric ratios for triangle ABC are. So let us do one thing. We have to know which angle we are talking about. Based upon that, there will be the ratio. So let us say we want trigonometric ratios of with respect to angle C, right? So sine is opposite, right? Opposite by hypotenuse. So this will be BA divided by CA. So since this is 90 degree, this will be the hypotenuse. Okay. And cos C will be adjacent. So this is the side that is adjacent to it, right? CB divided by CA is the hypotenuse. tan C will be opposite divided by adjacent, that is BA divided by CB. So just the reciprocal, taking the reciprocal of these three will give us the other three. So sin C's reciprocal is cosec C. This would be opposite, hypotenuse divided by opposite, that is CA divided by BA, and reciprocal of cos is sec. Sec C is equals to hypotenuse divided by adjacent, that is CA divided by CB, and cot C is the reciprocal of tan C. Tan C was opposite by adjacent, so cot will be adjacent by opposite, that is CB divided by BA. Here in this triangle, let's say tan A is opposite by adjacent, so opposite is CB divided by adjacent is BA. So you know that for a numerator and denominator, if we multiply or divide both by the same number, the resultant fraction would be same. So let us do one thing, let us divide this both by CA, that is the hypotenuse. So dividing both CB divided by CA whole divided by BA is also, let's divide BA also by CA, right? So CB by CA is our sin A, right? Sin A is nothing but CB by CA. Similarly, cos A here is AB by CA. So this will be, substituting these things here, this will be sin A divided by cos A. So tan A is equals to sin A by cos A. So instead of A, if it would have been C, tan C is equals to sin C by cos C. And we use theta, it's a Greek letter, we use theta to indicate the angle. If I say this is theta, then tan theta is equals to sin theta divided by cos theta. Okay. Using the same logic, we can get cot theta is equals to cos theta divided by sin theta. This is anyway true because tan theta is cot theta is reciprocal of tan theta. Okay, to be clear, let's write the trigonometric ratios again. So we know sin theta is equals to 1 by cosec theta, and we know cos theta is equals to 1 by sec theta, right? So tan theta is sin theta by cos theta, right? So we can also write this as sin theta into sec theta, because cos theta is equals to 1 by sec theta. So I'm substituting this here. Tan theta is equals to sin by cos theta. Tan theta is equals to sin theta into sec theta. Similarly, tan theta is also is equals to 1 by cos theta. Now I'm taking the reciprocal of sin here, cos theta into cosec theta. Okay. Similarly, with respect to cot theta is equals to cos theta divided by sin theta, right? And just substituting these two here, we will get cot theta is equals to cos theta into cosec theta, or cot theta is equals to 1 by sin theta into sec theta. So you will need all these things when trying to solve proof questions. Do remember that the trigonometric ratios we were trying to find out were of the acute angles in the right triangles. Now let us find out the trigonometric ratios of some specific angles. And as you might be knowing, the angles are 45 degree, 30 degree, 60 degree, 0 degree and 90 degree. So we will look at all of these individually. So we will first see 40 degree, then we will see both 30 and 60, and then we will individually see 0 and 90. Okay. Okay, first let us see the trigonometric ratios of 45-degree angle. Let's take this example. This is 90-degree angle. So this is hypotenuse, right? And here let's assume the length of both the sides apart from hypotenuse are same. So if this is 1, this would be 1. So using Pythagoras theorem, we can, let's say the name of triangle is ABC. So using Pythagoras theorem, we know that AC square is equals to CB square plus AB square. So CB is 1 and AB is 1. So squaring them, we get 1 plus 1 is 2. So AC square is equals to 2, and so we'll get AC as root 2. So we are assuming this as 1, right? The length of both the sides are equal and they are 1. So in that case, the hypotenuse will be 1 by root 2. Okay. Let me also tell you that since the angle we are talking about is 45-degree and we know that this is 90-degree, the remaining angle will also be 45-degree, because we know the sum of all the angles in a triangle is 180-degree, right? Since one is already 90, the sum of remaining two angles should be 90. And as I said here, we are assuming that one side, the one angle is 45 degrees. So the other angle will also be a 45-degree angle, right? So if we see the sine of, let us say we are looking at sine of angle A, right? So sine of angle A is opposite divided by hypotenuse. So from here, opposite is 1 by 2. Opposite is 1 and hypotenuse is root 2. So sine A is 1 by root 2 and cos A is, that too is again 1 by root 2, because here opposite and adjacent are same. So cos A is again 1 by 2. So this will lead to tan is equals to 1 by 1 or 1. Conversely, cosec A is root 2. Sec A is also root 2. I am just taking the reciprocal of the above, and cot is again 1. Okay. Next, let us look into the trigonometric ratios of angle 30 and 60. Let us assume this is an equilateral triangle. Okay. Let us assume this is an equilateral triangle. So since this is an equilateral triangle, all the sides are equal. Okay. All the sides are equal and all the angles are of 60-degree. All right. Let's do one thing. Let us draw a perpendicular here. Okay. So this is the perpendicular. Let us say, let us give the name here. So let us say ABD is an equilateral triangle and we have drawn perpendicular AC to line BD. So here we get two triangles, one is ABC and the other one is ACD, right? So this perpendicular also acts as an angle bisector. So each of these angles are 30-degree. So this is a 30-degree angle, this is another 30-degree. That's how they both make 60-degree, and this 60, including everything, we get total sum as 180-degree. Okay. So let us just concentrate on triangle ABC. So here there is 30-degree right here, and let us assume that the total length of the side, length of each side is 2, right? It can be 2 centimeter, 2 meters, right? It is 2 units. Let us take it is 2 units. So this is also 2 unit, and since we have divided this, BC is 1, right? We'll just concentrate on the triangle ABC. So here in triangle ABC, with respect to the angle A here, that is the 30-degree angle, we get sine 30 is equals to, this is hypotenuse here, right? This is the right angle, 90-degree angle. So this will be the hypotenuse. So sine 30 would be opposite by hypotenuse, that is 1 by 2. Okay. And for getting the cos, we need to find AC. But we know by Pythagoras theorem that AB square is equals to BC square plus AC square. We know that AB square is 2 square and BC square is 1 square, right? So we need to find AC square. AC square is equals to 4 minus 1 is 3, right? So AC is root 3. So as we saw here, AC is root 3. Okay. So we got sine 30 is equals to opposite by hypotenuse, that is 1 by 2. So cos 30 would be adjacent by hypotenuse, that is from 30 adjacent is root 3, right? Root 3 by 2, and tan 30 would be opposite by adjacent, that is 1 by root 3. Okay. Reciprocating all this, we get that cosec 30 is 2, 2 by 1 or 2, and sec 30 is 2 by root 3, and cot 30 would be root 3, right? Cot 30 is adjacent by opposite, that is root 3 by 1. So these are the ratios for angle of 30 degree, right? If you are wondering why we are discussing sine 30 is equals to 1 by 2 or cos 30 is equals to root 3 by 2 in detail, bear with me for some time. You will soon come to know, because I could have directly told you that cos 30 is 1 by root 3, right? We are deriving them individually. You will come to know the reason a bit later. We'll be using the same triangle. We have our 60 degree here. So sine 60 will be opposite, that is root 3 by hypotenuse, that is 2. So sine 60 is root 3 by 2, and cos 60 is adjacent, that is 1, and the hypotenuse is 2. So we have tan 60 as opposite by adjacent, right? So root 3 by 1. You'll also get by dividing sine 60 by cos 60 as root 3 by 1. So tan 60 is root 3 by 1. We'll just take the reciprocal of all this. Cosec 60 is 2 by root 3. Sec 60 is 2, and cot 60 is 1 by root 3. Okay. Now let us look into the trigonometric ratios of 0 degree. Okay. So this is our triangle ABC. So this is 90 degree. We have 90 degree at angle at B, and AC is our hypotenuse. Okay. So here angle C is not exactly 0, right? I have used this picture to indicate that the A is almost coming to B. So this is not yet 0, but it is almost coming to 0, right? The angle C is almost coming to 0. So here let us try to find out the ratios. Let us also assume that BC is 1 unit, right? So since the angle C is almost 0, it is coming to 0, the angle, the side AC will also be 1, because it will be almost interlapping on BC, right? So since this is 1, this also will be 1, and as the angle C is coming to 0, AB will also be 0, right? AB will be 0 units. So sine 0 is opposite divided by hypotenuse, right? Opposite is 0. 0 by hypotenuse is 0 by 1. 0 by 1 is 0. Okay. Cos 0 would be adjacent by hypotenuse. 1 by 1 is 1. Tan 0 would be opposite by adjacent, that is 0 divided by 1. So we have again 0. Okay. We got sine, cos, tan. Now we will do the reciprocals. Cosec 0 is the reciprocal of sine 0, right? So now it will be 1 by 0. 1 by 0 is not defined. And reciprocal of cos is sec 0. So 1 by 1 is again 1. Cot 0 would be again same, 1 by 0, which would be not defined. Right? We'll also see the trigonometric ratios of 90 degree quickly. and here let this be triangle ABC, and again our 90 degree is at B. Okay, so the angle C is not exactly 90 here, but we are assuming that it is almost coming to B, so that it will also be 90 degree. So when angle C is almost 90 degree, let us assume that the side AB is 1 unit. So since the angle C is almost approaching 90 degree, then AC will almost interlap to AB. So this result in the length of AC would also be 1 unit. Okay, and the side BC will almost be 0. Okay, let us find the ratios. So sine 90. So we are doing this with respect to C here. So we are assuming this C is 90 degree. Okay, in the image it is not at 90, but we will do our calculation based upon this. So if C is almost coming to 90, then sine 90 is opposite by hypotenuse, that is 1, and cos 90 would be adjacent by hypotenuse. Since this is 90 degree, this is our hypotenuse. Okay, so adjacent is 0, almost 0, right? 0 by 1. 0 by 1 is nothing but 0, and tan 90 will be opposite by adjacent, that is 1 by 0. This is not defined. Okay, so let us see the reciprocals too. Cosec 90 would be again 1, sec 90 would be 1 by 0, again this will be not defined. So we can't define anything that is being divided by 0. So we get our cot 90 is 0 by 1, which is nothing but 0. Okay. Okay. So they have given this table in your textbook. So it shows all the trigonometric ratios of all the angles that we saw just now. And it is very important that you guys remember this, because you will get questions from this table, and there are tricks to remember this. One of the tricks is, it is enough to know sine of all the angles. So here, let's say sine theta is for 0, 30, 45, 60 and 90. You just need to know that the series is 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. So for sine of any angle, the ratio from 0 to 90 would be 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. So if you remember this, the cos will be opposite of this. Yeah, these are 0, 30, 40, 60 and 90. Okay. So cos theta will be reverse of this series. So if you remember 0, 1 by 2, 1 by root 2, root 3 by 2 and 1 for sine, you can just write 1 root 3 by 2, 1 by root 2, 1 by 2 and 0 will be here. So we are just reversing the series for sine. That will give us cos. And tan, we can directly find tan just by dividing sine divided by cos. So 0 by 1 is 0. 1 by 2 divided by root 3 by 2 is 1 by root 3, and this will be 1, and this will be root 3. 1 by 0 would be not defined. So this is how you get tan theta. Okay, and other three, that is cosec, sec and cot, will be the reciprocal of these. So if you know this, you can just work out the reciprocal of these. This was one method, but there is another method how I remember this. So most of the time you will be solving a 1 marker question or 2 marker question. So that time it is cumbersome to write all the table and then getting the values from it. Instead of that, there is an easy way. You just need to know 4 diagrams, right? 4 triangles. One would be this 45-degree triangle. The second would be this half equilateral triangle. Third would be this triangle that we saw. Actually, these are all the 4 triangles that we saw. Okay. Let us say this is 90 degree here, and this is 90 degree here. This is 90 and this is 90. Okay. Let us see a question where we need to find sine 30, okay, cos 30, tan 45, cosec 60, sec 90, tan 0. Okay. Let us see how we can find this by just remembering these 4 triangles. By the way, these 4 triangles are the triangles that we saw just earlier. So let us say we need to find sine 30. Sine 30 is, we saw that this was 1, 2, root 3. So this is half of the equilateral triangle. Let me just show you. So we saw in this slide that this was the half of an equilateral triangle, and using this we found both the ratios of 30 degree and 60 degree, right? So again we will try to do the same here. So this was 1, this was half of the side of the equilateral triangle, so this was 2, and we saw this root 3. Okay, so sine 30 would be opposite by hypotenuse, that is 1 by 2. Okay, cos 30 would be, again we have 30 here, cos 30 is adjacent by hypotenuse, that is adjacent is root 3 by 2. Tan 45 is, again tan is 45 degree angle is this, or even you can take this, both will give the same result. Okay, opposite by adjacent, that is 1 by 1 is 1. So here this was root 2, right? So this was our angle, this was 0, 1, 1, and this is our 90 degree, this is also approaching 90 degree, so this would be 1, 1 and 0. Okay, cosec 60, again here cosec is reciprocal of sine, right? Sine 60 is root 3 by 2, cosec would be 2 by root 3. Let us try to find out sec 90. Here this angle is almost reaching to 90, right? So sec is reciprocal of cos. So cos 90 is adjacent, that is 0, divided by hypotenuse, that is 1. Okay, so cos is 0 by 1, sec cos 90 is 0 by 1, sec 90 would be 1 by 0. So the answer is not defined. Let us try to find tan 0. So again here tan would be opposite by adjacent. So 0 by 1 is again 0. I know it might seem complicated, but you will see this, you will see the advantages of this while solving the questions. And you don't have to stick to this method itself if you are comfortable with the way you are doing it till now. That is, if you are comfortable by hearting the table, please do that. If you have already practiced with one method, it's okay, but I can't remember the table, so I am using this method. So just remembering these 4 triangles, generally just these 2 triangles, mainly this triangle, right? Most of the time the questions will be with respect to 30 degree or 60 degree. So most of the time we will be using this triangle. When there is a need for 45 degree, we will use this, or when there is need for 0, we will use this. When there is need for 90 degree, calculations related to 90 degree, we use this triangle. Okay. And another important thing you have learned in your previous class is Pythagoras theorem. So with respect to any right angled triangle, we can use Pythagoras theorem. Let us say this is triangle ABC. Pythagoras theorem says the square of the hypotenuse is equal to the sum of square of each sides. That is, CB square is equals to CA square plus AB square. You know this from your earlier classes. This is very important to remember for us here, because we will be deriving 3 trigonometric identities from this. Okay, so this is our left hand side, this is our right hand side, and you know that if we multiply or divide both left hand side and right hand side, the value will be same. Okay, so what we will do is we will divide this equation by each of the sides. Okay, first we will be dividing the whole equation by the square of hypotenuse. So we will get CB square divided by CB square. The hypotenuse is this, right? Is equals to CA square by CB square plus AB square by CB square. Right? CB square by CB square is 1. CA square by CB square is, so CA by CB, right? So with respect to angle B, CA by CB is nothing but sine of B, sine square of B. Okay, so sine of B is CA by CB, and since this is the square, we are writing this sine square of B. So again, with respect to B, AB by CB square is nothing but cos B square. Okay, cos square of B. So this is our first trigonometric identity. An equation is called an identity when it is true for all the cases, right? So if the angle was theta, then this would be sin square theta plus cos square theta is equals to 1. Okay, this is true when the theta is either equal to or greater than 0, or it is equal to or less than 90 degree. This equation holds true. So the first trigonometric identity for us is sin square theta plus cos square theta is equals to 1. Okay, this time we will divide the whole equation by CA square. Okay, so this will give us CB square divided by CA square is equals to CA square divided by CA square plus AB square divided by CA square. Okay, so with respect to angle B, CB by CA, so CB divided by CA, CB is hypotenuse, right, and CA is the opposite side. So opposite by hypotenuse is sine, and reverse of reciprocal of sine is cosec. Cosec square B is equals to CA square by CA square is 1 plus AB square by CA. So AB is, with respect to B, AB is the adjacent side and CA is the opposite side. So adjacent by opposite is cot, right? So this will be cot square B, and if we use theta for any angle, so we'll get the next trigonometric identity, that is 1 plus cot square theta is equals to cosec square theta. Okay, so if you see this table, cosec 0 and cot 0 are not defined. So here this is defined, this equation holds good when theta is more than 0 or less than or equals to 90 degree. Okay, this is a second trigonometric identity. This time we'll divide the whole equation by AB square. Okay, so CB by AB square is equals to CA by AB square plus AB by AB square. Okay, so CB by AB is, CB is hypotenuse, AB is our adjacent side. We are looking it with respect to B. So adjacent by hypotenuse is cos, and hypotenuse by adjacent would be sec B, right? So sec B, sec square B is equals to CA by AB. So CA is opposite divided by AB is adjacent. CA by AB would be tan. Okay, so this is tan square B plus AB by AB is 1. So we get the identity as 1 plus tan square B is equals to sec square B. And again, using let us use theta. So for general, for any angle, 1 plus tan square theta is equals to sec square theta. So this is our third trigonometric identity. Okay, and again, if we see the table here, for tan and sec, 90 is not defined, 90 degree is not defined. So this equation holds good then the theta is less than 90 degree or more than or equals to 0 degree. Okay, so we got 3 trigonometric identities. Again, you have to remember them because they will be useful for solving the questions. Okay, let us look at previous year questions. you must be knowing that practicing is the only way to get mastery in this chapter. Okay, so practice as much as you can, and I want you to pause the video and attempt the question for yourself. So try to get the answer, then you proceed. Okay, right, let's start. So first we'll look at multiple choice questions, that is 1 marks questions. If theta is an acute angle and 7 plus 4 sine theta is equals to 9, then the value of theta is. So they have given 7 plus 4 sine theta is equals to 9. So we can simplify. 4 sine theta is equals to 9 minus 7, that is 2. So sine theta is equals to 2 divided by 4, that is nothing but 1 divided by 2, and we know that sine 30 is 1 by 2, right? So theta is 30 degree. So the answer is B. Let's look at this next question. The value of tan square theta minus 1 divided by cos theta into sec theta is, okay, they have given tan square theta minus 1 by cos theta into sec theta, right? Okay, so 1 by cos theta is nothing but sec theta, right? So we can write tan square theta minus sec square theta, right? So we have an identity which is 1 plus tan square theta is equals to sec square theta. So they are asking for tan square minus sec. So we will bring sec this side and we will bring 1 this side. So this will be tan square theta minus sec square theta. So if 1 goes this side, it will be minus 1. So the answer is minus 1. Let's look at this next question. 7 cos square theta plus 3 sin square theta is equals to 4. Then the value of theta is, okay, 7 cos square theta plus 3 sin square theta. We know that cos square theta plus sin square theta is 1. So we have 3 sin square theta. So we will break 7 cos theta into two parts. One is 4 cos square theta and 3 cos square theta. Let's do here. 7 cos square theta plus 3 sin square theta is equals to 4. So we will break this 4 cos square theta plus 3 cos square theta. We are breaking this 7 into 4 and 3, right? Plus 3 sin square theta is equals to 4. So this will be cos square theta plus sin square theta, right? So we know this identity, sin square theta plus cos square theta is equals to 1, right? So this will be 1 and this will be 4 cos square theta, right? 4 cos square theta plus 3 is equals to 4. If we take 3 this side, this will be 4 cos square theta is equals to 4 minus 3 is 1. So cos square theta is equals to 1 by 4. Let us take cos theta, then we'll get the what angle theta is, right? Cos theta is equals to, it can be either plus 1 by 2 or minus 1 by 2, and we know that it can't be negative. So cos theta is equals to 2, and we know that cos 60 is 1 by 2, right? So the answer is C, 60. Okay. Next question. If sin 30 into tan 45 is equals to sec 60 by k, find the value of k. So they have given sin 30 into tan 45, right, is equals to sec 60 divided by k. Okay. This is 60, this is 30, 1, 2, root 3. So sin 30 is 1 by 2, right? 1 by 2 into tan 45 is nothing but 1, right? into 1 is equals to sec 60. Sec 60 is the reciprocal of cos 60. Cos 60 is adjacent by hypotenuse 1 by 2, right? So sec 60 would be 2 by k. We'll just simplify this. So k is equals to 2 into 2, but 4. Answer is A, 4. Let's look at the next question. Sin theta plus sin square theta is equals to 1. Then find the value of cos square theta plus cos 4 theta, right? Okay. They have given sin theta plus sin square theta is equals to 1. So if we simplify this, this will be, we can write this as sin theta is equals to 1 minus sin square theta. We know that sin square theta plus cos square theta is equals to 1. So cos square theta is equals to 1 minus sin square theta, right? So this will be cos square theta. Okay. So we get sin theta is equals to cos square theta. If we just substitute this in the given equation, we get that cos square theta plus this is sin square, right? So cos square of square will be cos 4 theta is equals to 1. They are asking, then the value of cos square plus, the answer is 1, right? Answer is A, 1. Let's look at this next question. Cot theta plus tan theta equals, they have given cot theta plus tan theta, right? So cot theta is nothing but 1 by tan theta plus tan theta. So this is equals to 1 plus tan square theta divided by tan theta, right? And we know the identity 1 plus tan square theta is equals to sec square theta. So this would be sec square theta divided by tan theta. Sec is nothing but reciprocal of cos, right? So this would be cos square theta, and tan is sin theta divided by cos theta. So this cos gets cancelled. So this would be 1 by cos theta into sin theta. So sin theta cos sec. Okay, let us just take the reciprocals of those. 1 by cos is sec theta and 1 by sin theta is cosec theta. Yeah. So the answer is A. Let's look at this next question. So if sin theta plus cos theta is equals to root 2 cos theta, where theta is not equal to 90 degree, then tan theta is equals to, okay. So they have given sin theta plus cos theta is equals to root 2 cos theta, right? So if we divide the whole thing by cos theta, we will get tan theta plus 1 is equals to root 2, right? Yeah, we got it, right? So tan theta is equals to root 2 minus 1. So here we divided the whole equation by cos theta. We can do that, right? So since we wanted tan theta, sin by cos will give us tan theta and cos will cancel itself. So this was the easiest thing that we could do. So tan theta is root 2 by 1. So the answer is B. Okay. Okay, let's look at this next question. If sin theta minus cos theta is equals to 0, then the value of sin to the power of sec theta plus cos to the power of sec theta is, okay. Sin theta minus cos theta is equals to 0. So this is given. So this means sin theta is equals to cos theta. So we know an angle where sin theta is equals to cos theta, that is 45 degree, right? So sin theta is equals to cos theta, in the sense this implies theta is equals to 45 degrees, right? Okay. So what they have asked is sin to the power 6 theta plus cos to the power 6 theta is equals to, and we also know that sin theta is equals to cos theta, right? So we'll just substitute here. So this means sin to the power 6 theta plus, instead of cos I'll take sin here. You can even take cos here instead of sin, right? So 6 theta, this is equals to 2 times sin 6 to the power theta. So we know that theta is 45 degree, right? So 2 into sin 45 is 1 by root 2, right? To the power of 6. This we will actually open it up. This we will actually take it into 3 into 2, right? So squaring 1 by root 2 will be 1 by 2 to the power 3, right? This will be 2 into 1 by 8. So the answer is 1 by 4, right? So the answer is D. Okay. Next question. If triangle ABC is right angled at C, let's say this is a right angled triangle. Okay. So they are telling that this is right angled at C. Okay. Then the value of cos A plus B is, okay. So here in this triangle, angle A plus angle B plus angle C is 180 degree, and we know that angle C is 90 degree, right? Angle C is 90 degree. So the sum of other two angles will also be 90 degree, that is angle A plus angle B is equals to 90 degree. Okay. So they are asking then the value of cos A plus B. So basically they are asking cos 90. Cos 90 is nothing but 0. Okay. So the answer is D. Simple, right? Okay. Let's look at this next question. Tan 2A is equals to 3 tan A. Tan 2A is equals to 3 tan A is true when the measure of angle A is dash. Okay. So angle A is either 90, 60, 45 or 30, so that it satisfies this equation, right? 2A is equals to 3 tan A. We can try by substituting 2 into 90, right? Okay. So this is actually tan 180. In the first case, that is 90, we are not at all dealing with the angles more than 90 in our chapter here, right? So this is not an answer. So again, in 62, so tan 2 into 60 is tan 120. Again, we are not dealing that here in our chapter. So C is possible because 45 into 2 is 90, right? Is equals to 3 tan A, 3 tan 45. Tan 45 is 1, so 3 times 1, and this is tan 90, right? Tan 90 is 1 divided by 0, right? This is not defined. So this too is not the option. So the answer will be the third one, right? 30 degree will be the answer. But anyway, let us check. If 3 of those doesn't satisfy, automatically the fourth will satisfy. Let us check. Tan 2 into 30 is 60 is equals to 3 tan 30, right? Tan 60 is, sin 60 is root 3 by 2. Okay, let me do one thing. Let me just quickly draw this here. 31 to root 3. So tan 60 is opposite by adjacent, right? This is hypotenuse, opposite is root 3 by 1 is equals to 3 times tan 30 is again opposite by adjacent, 1 by root 3. So root 3 will go this side, root 3 into root 3 is equals to 3. Yeah, that is true actually. So the answer is D. Which of the following statement is true? Sine 20 is greater than, okay, they are asking the values, right? We don't know what sine 20 is, we don't know what sine 70 is, right? Yeah, most of them are 20 degree and 70 degree. But we do know 30 degree and 60 degree, right? So let us say if sine 20 is greater than sine 70, this means sine 30 should also be greater than sine 60, right? Because sine 30 comes before sine 20 and sine 60 comes before sine 70. So if instead of 20 we will take 30 and instead of 70 we will take 60 and we will compare. So if 30, if the relationship is true for angle 30 degree and 60 degree, it will also be true for 20 degree and 70 degree. Okay. First one, if sine 20 is greater than sine 70, right? So let me just draw my triangle here. This is 1, this is 2, this is root 3, 30 degree, 60 degree. Okay. Sine 30 is 1 by 2. 1 by 2 is greater than sine 60 is root 3 by 2. This is wrong. Okay. Next one is sine 30, sine 20 is greater than cos 20, right? We'll see if sine 30 is greater than cos 30. Okay. Sine 30 is 1 by 2. Okay. Cos 30 is root 3 by 2. Greater than root 3 by 2. Again wrong. We'll check D. We'll check C. Cos 20 is greater than cos 70. Right. We'll check cos 30 is greater than cos 60. Right. Cos 30 is root 3 by 2. Cos 60. Right. Cos 60 is 1 by 2. This is correct. Okay. Let us still, so the answer is actually C. Let us just check this too, greater than tan 70, right? So we will check tan 30 if it is greater than tan 60. So tan 30 is 1 by root 3. So this should be greater than tan 60, right? Tan 60 is root 3 by 1. This is wrong. So the answer is C. Okay. Another question. If tan 3 theta is equals to root 3, then theta by 2 equals. Seems to be very simple. Let us check. So they have given tan 3 theta is equals to root 3. Okay. Then theta by 2 is equals to. So for what value tan theta is root 3? We have to check, right? So sine would be 0, 1 by 2, 1 by root 2, root 3 by 2, 1. Cos would be opposite 1, root 3 by 2, 1 by root 2, 1 by 2, 0. So obviously 0 and 90 are not the answers here. Again, the answer is this, right? Again, 45 will definitely not be the answer. The only possibility are either 30 degree and 60 degree now, and we have seen here that tan 60 is root 3. So tan 60 degree is equals to root 3. So this implies 3 theta is equals to 60, right? Theta is equals to 20 degree. So they are asking theta by 2, theta is 20, right? So this is equals to 20 divided by 2 is 10 degree. So the answer is D, 10. Okay. Let's see the next question. If x is equals to p cos cube alpha and y is equals to q sin cube alpha, then the value of, okay, x by p, right? So they have given x is equals to p cos cube alpha. So instead of theta or a or b, they have given alpha. That's it. Okay. And y is equals to q into sine cube alpha, right? So let us just substitute these values in the given operation, right? So they have given x divided by p to the power 2 by 3 plus y divided by q to the power 2 by 3, right? So we know x is p cos cube alpha divided by, we have p here, right? This to the power 2 by 3 plus y is q sine cube alpha divided by q, right? So we want to find the value of this. P gets cancelled here, right? Same with the q. So we get, let me just write it here. So we get cos cube alpha 2 by 3 to the power 2 by 3, right? Plus sine cube alpha to the power 2 by 3. So actually 3 gets cancelled. So this results into cos square alpha plus sine square alpha, right? Which is equals to 1. Okay. So the answer is A. Okay. Let's see the next question. 1 minus tan square 30 degree divided by 1 plus tan square 30 is equals to. Okay. So what is tan 30? Tan 30 is 1 by root 3, right? So let us take that 1 minus tan square, let me write it here, tan 30 degree is equals to 1 by root 3. Okay. So square of this would be 1 by 3. 1 minus 1 by 3 divided by 1 plus 1 by 3. So this would be 3 minus 1 by 3 whole divided by 3 plus 1 divided by 3. 3 minus 1 is 2. 2 divided by 3 divided by 3 plus 1 is 4 divided by 3, right? This is nothing but 2 by 3 into 3 by 4. So this equals to 1 by 2. So we have to check sine 30, right? We have to check if these values, any of these values equals to 1 by 2. So sine 30 is 1 by 2, but cos 60 is 1 by 2. So the answer is, right? So the answer is B. Okay. Let's look at this next. Let us see the reason first. Anyway, reason is true, right? So the reason they have given is sin square theta is equals plus cos square theta is equals to 1, and for this is for any value theta which is less than or equal to 90 degree, or any value of theta which is equal to or more than 0 degree. So this is true, right? Reason is true. Let us see the assertion too. For an acute angle theta, sin theta is equals to 3 by 5. So for an acute angle theta, sin theta, so this will be cos theta is equals to minus 4 by 5. We can actually put these readings here and get the answer. But the thing is, cos for they have given that the theta is an acute angle, right? For theta, if it is in the range of 0 to 90 degree, then the value of cos will be positive, and again that will be within the range of 0 and 1. So theta will be either it will be 0 or more than 0, or it will be 1 or less than 1, right? So it won't be in a negative value. So assertion is wrong. Okay. Let's look at this next question. From the given figure, find the value of sine alpha. So they have given this is sine alpha, right? So we know sine of any angle is equals to opposite of that angle divided by hypotenuse, right? Okay. So for this angle, you would be tempted to see that this is the opposite and this is the hypotenuse, right? Since you are taking the right angle here. But that calculation will be cumbersome. And I think this is most probably a 2-mark question, so it won't be that complicated. Instead of that, you can see the 90-degree angle here, right? So in this, let us just name this triangle A, B, C, D, right? So instead of at the first instinct, just by looking the diagram that they have given, you would feel that you have to calculate the AC and that you have to divide by AD, then you will get the sine alpha. But instead of that, what I am telling is, instead of considering triangle ACD, you should consider triangle ABD. From the perspective of triangle ABD, sine alpha is equals to, so opposite is AB, right? AB divided by hypotenuse here is DB. For this triangle, hypotenuse is DB. So sine alpha is equals to 6 divided by 12 centimeters. So the answer is sine alpha is equals to 1 by 2. When the figure is given, study it thoroughly and see that you get the answer very quickly. Okay. Let's look at this next question. If x cos 60 plus y cos 0 plus sin 30 minus cot 45 is equals to 5, then find the value of x plus 2. Okay. So x cos 60 is, cos is adjacent by hypotenuse, 1 by 2, right? Plus y cos 0. Y cos 0 is 1, right? Plus sin 30. Sin 30 is again 1 by 2, right? Minus cot 45. Tan 45 is 1. So cot 45 is also 1 is equals to 5. Let us just simplify this. X divided by 2 plus y plus 1 by 2 is equals to, let me take 1 that side. So it will be 5 plus 1 is 6. Next would be x divided by 2 plus y is equals to 6 minus 1 by 2, that is nothing but 11 by 2, right? So multiply the whole equation by 2, we get that x 2 gets cancelled plus 2y is equals to 11, right? Okay, that is the answer. All right, let's look at this next question. If sine 2a plus 3b is equals to 1 and cos 2a minus 3b is equal to root 3 by 2, okay, find a and b. They have given sine 2a plus 3b is equals to 1, right? So this means we know that sine 90 is equals to 1, right? So this implies 2a plus 3b is equals to 90, right? And similarly, they have given cos 2a minus 3b is equals to root 3 by 2. And we know that cos 30 degree is equals to root 3 by 2. So 2a minus 3b is equals to 30. So we have equation 1 here, we have equation 2. We'll just subtract the second equation from first equation. That is 2a plus 3b is equals to 90 minus 2a minus minus is plus 3b is equals to minus 30, right? 2a minus 2a is 0 plus 3b plus 3b is 6b is equals to 90 minus 30 is 60. This implies b is equals to 10, right? Okay, let us substitute here to get our a. 2a minus 3 into 10 is equals to 30. 2a is equals to 30 plus 30, that is 60. A is equals to 60 divided by 2, nothing but 30, right? Let's look at this next question. If tan A is equals to root 3, where A is an acute angle, then find the value of sin square A divided by 1 plus cos square A. So this is a 2 marks question. Tan A is equals to root 3, right? Okay, root 3 means it will be either 30 or 60, right? Tan 60 is equals to root 3, right? So A is equals to 60. So we have sin square A divided by 1 plus cos square A is what they are asking, right? Sin square A is nothing but sin 60, sin square 60 divided by 1 plus cos square 60. So root 3 by 2 whole square divided by 1 plus cos 60 is adjacent by hypotenuse. So 1 by 2 whole square. So this will be 3 by 4 divided by 1 plus 1 by 4, right? So 1 plus 1 by 4 is nothing but 5 by 4. 3 by 4 divided by 5 by 4. This is equals to 3 by 4 multiplied by 4 by 5. The answer is 3 by 5. Okay. Let's look at this next question. Again a 2 marks question. If 4k is equals to tan square 60 minus 2 cosec square 30 minus 2 tan square 30, then find the value of k. They are asking tan 60 and cosec 30, tan 30, right? So tan 60 is equals to cosec 30 is equals to, we need to find this. So if we get this, we can just substitute and get our answers. Tan 30 is opposite by adjacent, that is 1 by root 3. Cosec 30 is reciprocal of sin 30. Sin 30 is 1 by 2, cosec 30 is 2. Tan 60, right? So opposite by adjacent, root 3. So we have 4k is equals to tan 60 is root 3 square is 3, right? Minus 2 times cosec 30 is 2 square is 4 actually, minus 2 tan 30 is 1 by root 3, right? Square of 1 by root 3. 4k is equals to 3 minus 4 into 2 is 8 minus 2 by 3. Okay. 3 minus 8 is minus 5 minus is equals to minus 15 minus 2 divided by 3, right? So this comes to minus 17 divided by 3. 4k is equals to minus 17 divided by 3. This implies k is equals to minus 17 divided by 12. This is the answer. Okay. Let's look at this next question. This we can use the formula. Actually, we know that sin square theta plus cos square theta is equals to 1, right? So we need to get these in terms of sin square theta plus cos square theta. So this is, so if sin square theta is a and cos square theta is b, so this is in the form of a square plus b square. So we have a formula, right? A plus b whole square is equals to a square plus b square plus 2ab, right? So we want a plus b whole square, right? So we want this in terms of a plus b whole square, right? So we have a square plus b square. So this is equals to a plus b whole square minus 2ab, right? We will do this operation here, right? And coming to this part, so again we want to use this identity. Let's assume sin square is a and cos square is b. So this is in the form of a cube plus b cube, right? And we know the formula a plus b whole cube is equals to a cube plus b cube plus 3ab into a plus b, right? So we want this in terms of this. So a cube plus b cube will be a plus b whole cube minus 3ab into a plus b, right? We'll just do this operation on this. Okay, let's see. This will be 2 sin square theta plus cos square theta cube minus 3 sin square theta into cos square theta in brackets sin square theta plus cos square theta, right? Minus, let us keep this same, sin to the power 4 theta plus cos to the power 4 theta plus 1 is equals to 0. Okay. So let us just simplify this. We get this as 1 cube minus 3 sin square theta into cos square theta. Again, sin square theta plus cos square theta is 1. Let us open up this 2. So we have 3 into sin square theta plus cos square theta square minus 2 sin square theta into cos square theta. I'm sorry, the space is not much here. So let us just simplify this. 2 into 1 minus 3 sin square theta into cos square theta, right? Minus 3 into, this is 1. So 1 minus 2 sin square theta into cos square theta plus 1 is equals to 0, right? We need to simplify this. So this will be 2 minus 6 sin square theta into cos square theta, right? Minus 3, minus minus is plus 6 sin square theta into cos square theta plus 1 is equals to 0. So we have minus 6 sin square theta into cos square theta and plus 6 2 sin square theta into cos square theta. So minus plus is 0. So this will be 2 minus 3 plus 1 is equals to minus 1 plus 1 is equals to 0. Sorry, I took 0 here. Hence proved, right? Okay. Let's look at the next question. Evaluate tan square 60 divided by sin square 60 minus plus cos square 30. So we need the value of tan 60, sin 60 and cos 30, right? So here you can write, we know tan 60 is equals to sin 60 is equals to cos 30 is equals to, right? That's how you write the answer. Tan 60 is equals to opposite by adjacent, that is root 3. Sin 60 is again opposite by hypotenuse, root 3 by 2, and cos 30 is root 3 by 2 again. So plugging in the values here, we will get root 3 square divided by root 3 by 2 whole square plus root 3 by 2 whole square. So we get, this is nothing but 3 divided by 3 by 4 plus 3 by 4. So 3 divided by 6 by 4. 3 is divided by 6 by 4, which is nothing but 3 into 4 by 6. 3 2 times is 6, 2 2 times is 4. So the answer is 2. Okay. Okay, we know cot theta is equals to 1 by tan theta, right? So we can rewrite this as tan theta divided by 1 minus 1 by tan theta plus 1 by tan theta whole divided by 1 minus tan theta. This can be rewritten as tan square theta because one tan comes up the denominator here comes up, right? So this will be tan theta minus 1 plus 1 divided by tan theta into 1 minus tan theta, right? So here it is tan theta minus 1 and here it is 1 minus tan theta. So we'll bring this with just a change of sign. This is equals to tan square theta divided by tan theta minus 1 minus 1 by tan theta into tan theta minus 1. So since I changed the sign here, because of that, instead of plus, here comes minus. Okay. So now in denominator, this has extra tan theta. So we just need to multiply this by tan theta to get a common denominator. So this will be tan cube theta minus 1 divided by tan theta into tan theta minus 1. Okay. So this is almost like a cube minus b cube. Let me rewrite this in a fresh page. Okay. So we will take this as 1 cube, right? We know a formula where a cube plus b cube is equals to a plus b into a square plus b square plus ab, right? And a cube minus b cube is equals to a minus b into a square plus b square plus ab, right? So we'll just use this here. So this would be tan theta minus 1 into tan square theta plus 1 plus tan theta, okay, divided by, again we have tan theta into tan theta minus 1, right? So this gets cancelled out. So we'll be having tan square theta divided by tan theta, right? I'm just taking this tan theta individually, plus 1 by tan theta plus tan theta by tan theta is 1, right? And again tan theta gets cancelled here. So this is equals to, let me just take tan theta as sin theta divided by cos theta, okay? Cos theta plus 1 by plus sin theta divided by cos theta plus 1. So this is equals to sin square theta plus cos square theta divided by cos theta into sin theta, right? Plus 1. So we know that sin square theta plus cos square theta is equals to 1. So we'll be having 1 by cos theta into sin theta plus 1. Reciprocal of cos theta and sin theta are sec theta and cosec theta, right? Plus 1. So hence proved. Okay. Sorry, I made a mistake here. A cube plus b cube is equals to a plus b whole into a square plus b square. This should be minus ab, right? Let's do one thing. Let us look at the formulas in a fresh page. So we'll just look at few algebraic formulas that might be useful in prove it questions. So first we have the simple ones. A plus b whole square is equals to a square plus b square plus 2ab, right? And a minus b whole square is equals to a square plus b square minus 2ab, okay? Then we have a square minus b square is equals to a plus b into a minus b, right? We have a plus b whole cube is equals to a cube plus b cube plus 3ab into a minus a plus b, right? A minus b whole cube is equals to a cube minus b cube minus 3ab into a minus b, okay? Right. Then we have a cube plus b cube, which is equals to a plus b into a square plus b square minus ab, and other formula is a cube minus b cube is equals to a minus b into a square plus b square plus ab, right? We need to remember this to solve the questions. So other than this, we have three identities, right? Sin square theta plus cos square theta is equals to 1, and 1 plus tan square theta is equals to sec square theta, and 1 plus cot square theta is equals to cosec square theta. Let's look at this next question. So this is a 3 marks question. Prove that. Okay, let's write this here. Sin a plus cos a divided by sin a minus cos a plus sin a minus cos a divided by sin a plus cos a. So this is our LHS. So we'll just simplify this. So we will get, we'll try to get the common denominator. Sin a plus cos a whole square plus sin a minus cos a whole square, okay, divided by sin a minus cos a into sin a plus cos a. Okay, this is equals to, if you just open it, a plus b whole square is equals to a square plus b square, right? So sin a square plus cos a square is 1 plus 2ab, that is 2 sin a into cos a, plus again sin square a plus cos square a is equals to 1 minus 2 sin a into cos a. This is divided by a square minus b square, right? Sin square a minus cos square a. So 1 plus 1 is 2 plus 2 sin square a into cos square a minus 2 sin square a into cos square a. So it gets subtracted. So the resultant will be 0. What we get is 2 divided by sin square a minus cos square a, right? Okay. So we know sin square theta plus cos square theta is equals to 1. So cos square theta is equals to 1 minus sin square theta, right? So we'll just use this here. Sin square a minus 1 minus sin square a, right? So this will be 2 divided by minus minus is plus, right? So 2 sin square a minus 1 is equals to RHS. Hence proved. Okay. Let's try this next question. So LHS is this, right? So we'll do one thing. We'll try to get the same denominator. So this will result in sec a minus 1, right? So square of this plus sec a plus 1. Again this will be square of this, and here is a plus b into a minus b is a square minus b square, right? Okay. So the numerator will be sec a minus 1 plus sec a plus 1, right? And the denominator is, we know sec square a minus 1 is equals to tan square a, right? Because we have an identity 1 plus tan square theta is equals to sec square theta, right? So this is nothing but tan square a, right? Simplifying, we get minus 1 plus 1 is 0. So sec a plus sec a is 2 sec a divided by tan a, right? So simplifying, we get sec is nothing but cos A, right? Tan is sin by cos. Sin will be cosec A and tan would be sec A, right? Okay. Yeah, instead of cos, we will take it sec itself. 2 sec A into cosec A divided by sec A, right? So this gets cancelled. We get 2 cosec A is equals to RHS, right? Okay. So actually this whole thing depends upon this, using this identity. Actually I tried quite a few times and didn't get this, but since the time is short, I'm not showing you the wrong attempts that I did. So the most important thing is we have to use this identity here to get this, okay, right? Okay, let's look at this next question. So left hand side is 1 by cos. Okay, let's simplify this. So this would be 1 minus cos square A divided by cos A into 1 minus sin square A divided by sin A, right? So we know that sin square theta plus cos square theta is equals to 1, right? So we'll use that here. Sin square A divided by cos A into cos square A divided by sin A. Again, this cancels out. So we have sin A into cos A. So we have this as LHS, right? So RHS is completely different. Let us try to simplify RHS to is equals to 1 by tan A plus, let us take this 1 by tan A, right? So this would be tan A divided by tan square A plus 1, right? So tan square A plus 1 is nothing but sec square A, right? Because we have an identity 1 plus tan square A is equals to sec square A, right? So let us simplify this. Tan A is nothing but sin A by cos A. Sec is nothing but sec square A is nothing but cos square A, right? So cos cancels out. So we are getting sin A into cos A is equals to right hand side. So both are same. So LHS is equals to RHS. Okay. So we had to simplify the right hand side too. So we had to simplify LHS and we had to simplify RHS, and they both came to be sin A into cos A, right? Okay. Let's solve this next question. So LHS, let us try to simplify this. So this would be tan square theta plus 1 divided by tan square theta into cot square theta plus 1 divided by cot square theta. Okay. So we know that tan square theta plus 1 is nothing but sec square theta, right? Multiplied by cot square theta plus 1 is cosec square theta, right? Divided by cot square theta. So this would be sec square theta is nothing but 1 by cos square theta into tan square theta, right? Multiplied by cosec square theta is 1 by sin square theta, right? Into, let us take cot above 1 by, so this will be tan square theta. So this gets cancelled out. We have 1 by cos square theta into sin square theta, right? And we know that this cos square theta can be written as 1 minus sin square theta, right? So we'll do just that. 1 minus sin square theta into sin square theta, right? Yeah. So simplifying this, we'll get 1 by sin square theta minus sin square into square would be sin to the power of 4 theta. So this is our right hand side. So LHS is equals to RHS, right? Let's look at this next question. So we'll try to get a common denominator. So this would be root of cosec theta minus 1 to the whole square plus root of cosec theta plus 1 to the whole square divided by root of a plus b into a minus b is a square minus b, right? So we have an identity which is 1 plus cot square theta is equals to cosec square theta. So cosec square theta minus 1 is equals to cot square theta, right? We'll use this. So this would be in denominator, we will get root cot square theta, right? We are substituting this, and numerator would be cosec theta minus 1 plus cosec theta plus 1, right? Minus 1 plus 1 gets cancelled out. So this implies 2 cosec theta divided by cot theta, okay? So we can write cot theta as cot would be cos by sin, cos is sec theta and sin would be cosec theta, right? Okay. So we get 2 sec theta, which is nothing but RHS. So hence proved. Okay. Let's look at the next question. So they are asking to find the value of x, right? So they have given an equation. Okay, let's solve it. So sin a plus cosec a whole square is, let us open up it. So it would be sin square a plus cosec square a plus 2ab is 2 sin a into cosec a, right? Plus cos square a plus sec square a plus 2 cos a into sec a, right? So here this is equals to x plus tan square a plus cot square a, right? So here actually sin and cosec gets cancelled because cosec is nothing but 1 by sin. Similarly, cos and sec gets cancelled. So what we are getting is sin square a plus cos square a, right? Plus cosec square a plus sec square a plus 2 is equals to x plus tan square a plus cot square a, right? So this is nothing but 1, okay? 1 plus cosec square a plus sec square a plus 2 plus 2 is 4 is equals to x plus tan square a plus cot square a, okay? So let us try to use the identities here. Let's bring tan and sec one side and cot and cosec other side. So 5 plus sec square a minus tan square a, right, is equals to x plus cot square A minus cosec square A, right? We know that 1 plus tan square A is equals to sec square A. Let me rewrite it. So we have sec minus tan, right? Sec square minus tan square is equals to 1, right? So we'll use that. 5 plus 1 is equals to, this would be x minus 1, right? So this implies 5 plus 1 is 6, 6 plus 1 is 7 is equals to x. This implies x is equals to 7. So this is our answer. Okay. Let's look at this next question. Evaluate the following. Okay. We know sin 30 is 1 by 2, right? So if we simplify this, this would be 3 into 1 by 2 minus 4 into sin cube 30, right? So 1 by 2 to the power of cube divided by, let us, 2 is common here. So this would be sin square 50 plus cos square 50, which is nothing but 1, right? So this would be 3 divided by 2 minus 4 into 1 by 8, which is nothing but 1 by 2, right? Divided by 2. So this will be 3 divided by 2 minus 1 by 2 whole divided by 2, which is nothing but 2 by 2 is 1, divided by 2 is the answer. Okay. Let's look at this next question. So they are asking tan 30, right? Cos 45, sin 30, sin 60, cos 60 and cot 45. Okay. Tan 45 is 1, so cot 45 is also 1. Sin 30 is 1 by 2, right? Sin 60 is root 3 by 2. Cos 60 is 1 by 2. Cos 45 is 1 by root 2. Tan 30 is opposite by adjacent, 1 by root 3. Right, let us substitute them. This will be 5 into tan 30 is 1 by root 3, right? One by root 3 square plus 3 into cos 45 is 1 by root 2. So this would be 1 by root 2 whole square minus 4 into sin 30 is 1 by 2. Okay. Divided by under root 3, sin 60 is root 3 by 2, right? Into cos 60 is 1 by 2, right? Plus cot square 45 is 1, right? So simplifying this, we get 5 divided by 3 plus 3 divided by 2 minus 4 divided by 4 is 1, right? Minus 1 divided by 3 by 4 plus 1. Okay. So again further simplifying, we'll get 6 divided by 10 plus 9 minus 6, right? Divided by 3 plus 4 by 4. So this is nothing but 10 plus 9 is 19 minus 6 is 13. 13 divided by 6 divided by 7 divided by 4, or this is nothing but 13 divided by 6 into 4 by 7, 2 times 2, 2 times 3. So this is nothing but 13 into 2 is 26 divided by 21. So this is our answer. Okay. Let's solve this question. Prove that. Okay. So let's see what LHS is. It is in the form of a plus b into a minus b, right? So this would be a square minus b square, right? we know the identity sin square theta plus cos square theta is equals to 1, right? So sin square theta is equals to 1 minus cos square theta. And we also know the identity 1 plus cot square theta is equals to cosec square theta, right? So instead of cosec square theta, we will use 1 plus cot square theta here, and instead of sin square theta, we will use 1 minus cos square theta here. So this will be 1 plus cot square theta minus 1 minus cos square theta. So this would be 1 plus cot square theta minus 1 minus is plus cos square theta. So plus 1 minus 1 is 0, right? So cot square theta plus cos square theta, nothing but RHS. Okay. So this is LHS is equals to RHS. So proved. Okay. Let us look at this next question. Prove that. Okay. So if we can prove that this is minus cot theta, then this would prove itself, right? So let us see if we can prove cos theta minus 2 cos cube theta divided by sin theta minus 2 sin cube theta. So we have to prove this minus that this is minus cos theta, right? So let us see. Let us take cos as common. So this would be 1 minus 2 cos square theta divided by sin theta into 1 minus 2 sin square theta, right? Okay. So we know sin square theta is equals to 1 minus cos square theta, and cos square theta is equals to 1 minus sin square theta, right? So let us try to use that here. Cos theta into 1 minus cos square theta minus cos square theta, right? Divided by sin theta into 1 minus sin square theta minus sin square theta. Okay. So this would be cos theta into sin square theta minus cos square theta divided by sin theta into cos square theta minus sin square theta. So let us bring the minus here. So this will be minus cos theta into cos square theta minus sin square theta divided by sin theta into cos square theta minus sin square theta. So this gets cancelled out. We get this is minus cos theta divided by sin theta, which is nothing but minus cot theta, right? So this total, that is cos theta minus 2 cos cube theta divided by sin theta minus 2 sin cube theta is equals to minus cot theta, and we should and if we substitute this in our given equation, this would be minus cos theta plus cos theta, and this is equals to 0, this is equals to, so we have left hand side is equals to right hand side. So this is proved, right? I hope you got this. Okay. Let's look at this next question. Use the identity sin square a plus cos square a is equals to 1 to prove that tan square a plus 1 is equals to sec square a. Okay. So we have sin square a plus cos square a is equals to 1, and we need to prove that tan square a plus 1 is equals to sec a, right? So if we divide the whole equation by cos square a, we get that sin square a by cos square a is tan square a plus cos square a plus divided by cos square a is 1 is equals to 1 by cos square a is nothing but sec square a. So we got the first part. So we just need to divide this whole equation by cos square a, right? So hence find the value of tan a when sec a is equals to 5 by 3, where a is the acute angle. Okay, let's try to draw a right angled triangle, right? So a is somewhere here and 5 is the hypotenuse, because sec is nothing but 1 by cos, right? Sec a is 1 by cos a, and we know cos a is adjacent by hypotenuse. So sec a is equals to hypotenuse by adjacent. So hypotenuse is 5, adjacent is 3. They are asking to find tan a, right? Okay. So here we need to find this to find tan a, right? So let's say this is x. So x square is equals to 5 square, that is 25, minus 3 square is 9. So 16. X is equals to plus or minus 4, but here in this case it will be plus 4. So this is 4, right? So tan A is equals to opposite, that is 4, divided by adjacent, that is 3, right? This is the answer. So this is the first part, this is the second part. Okay. Let's solve this next question. So they have given, if sin A is equals to y, then express cos A plus tan A in terms of y. Let us take an imaginary triangle. Let us take a triangle and let us name this as ABC, right? So they have given sin A is equals to y. So here our sin A is opposite by hypotenuse, that is CB by CA, right? This is equals to y. So this implies, from here we can deduce that CB is equals to y into CA, right? So this would be y into CA. Okay. So cos A would be AB by CA, right? Or here from this we can also deduce that CA is equals to CB divided by y. Okay. So here we have CA. So this will be AB divided by CB into y. So AB is adjacent and CB is the opposite, right? Adjacent by opposite is nothing but cos A is equals to cot A into y. So we got our answer of cos A in terms of y. Next we will look at tan A. Anyway, tan A is equals to sin A by cos A. So sin A is y and cos A is cot A into y. Okay. Okay, we want this in terms of y, not we shouldn't actually get the y cancelled out. Let us see. Tan A is nothing but opposite by adjacent, right? So opposite is CB, adjacent is AB, right? CB is nothing but, as we saw here, it is y into CA divided by AB, right? CA divided by AB is, AB divided by CA is cos theta, and CA divided by AB is equals to y into sec theta. So here we have tan A is equals to, sorry, this is A, right? So this is A here. Tan A is equals to sec A into y. So this is our answers. Okay. Let's look at this next question. So it is given that sin A minus B is equals to Okay, sin A into cos B minus cos A into sin B. Use it to find the value of sin 15 degree. Okay, so we want to find 15 degree and we can use sin A minus B to do that, right? So yeah, we can use sin 60 minus sin 45 because we know the value of sin 60 and sin 45, right? So let A be 60 degree and B be 45 degree, right? Let A is equals to 60 degree and B is equals to 45 degree. Then sin 60 degree minus 45 degree is equals to sin 60 into cos 45 minus cos 60 into sin 45, right? So we know sin 60 is root 3 by 2, okay, and cos 45 is 1 by root 2 minus cos 60 is 1 by 2 into sin 45 is 1 by root 2, right? So we get root 3 by 2 root 2 minus 1 by 2 root 2. So the answer is root 3 minus 1 divided by 2 root 2. So this is our answer. Okay, let's solve this next question. So they have given cot theta plus cos theta is equals to P and cot theta minus cos theta is equals to Q. Prove that P square minus Q square is equals to 4 under root of PQ, right? Okay. So let us take LHS first. So left hand side is P square minus Q square. So we know a formula, A square minus B square is equals to A plus B into A minus B, right? So we will use that here. This would be P plus Q into P minus Q. Okay. So let us put the values here. This would be cot theta plus cos theta plus cot theta minus cos theta, right? This whole is multiplied by cot theta plus cos theta minus cot theta, minus minus gets plus here. So this is plus cos theta. So plus cos theta minus cos theta is 0 and plus cot theta and minus cot theta is 0. So this would be 2 cot theta into 2 cos theta, which is nothing but 4 cot theta into cos theta, right? So this is what we got in the left hand side. Let us try to simplify right hand side too, and let us see we can get the same thing. So RHS is equals to 4 under root PQ. So this means 4 under root P is cot theta plus cos theta multiplied by cot theta minus cos theta, right? So again, this is in the form of A plus B into A minus B. So this will be cot square theta A square minus B square, right? To cos square theta. So let us expand cot theta. This will be 4 under root cos square theta divided by sin square theta minus cos square theta. So we have cos square theta common here. If we bring them out, it will be this is equals to 4 cos theta under root 1 by sin square theta minus 1, right? So let us simplify this. This would be 4 cos theta into under root 1 minus sin square theta divided by sin square theta. So we know 1 minus sin square theta is cos square theta, right? 4 cos theta into cos square theta divided by sin square theta. Okay, so cos square theta by sin square theta is nothing but cot theta, right? cos theta into root of cot square theta, which is nothing but 4 cos theta into cot theta. So we got this both in LHS and RHS. So this implies left hand side is equals to right hand side. So we proved it. Okay, right. Let's look at this next question. So they have given an equation and we need to find the value of x, right? So this will be, let us try to expand this. Since this is in the form of a plus b whole square, we'll just open it. A square plus b square plus 2ab, right? That is sin a into cosec a. Plus similarly this is a square plus b square plus 2ab, right? That is 2 cos a into sec a. This is equals to x plus tan square a plus cot square a, right? Okay. So we know sin square plus cos square a, sin square a plus cos square a is 1, right? Plus so cosec a is nothing but 1 by sin a, so that would be, this gets cancelled out, and again sec a is nothing but 1 by cos a, so this gets cancelled out, so plus 2. What remains is cosec square a plus sec square a is equals to x plus tan square a plus cot square a. Okay, so this is nothing but, this is 5, right? So we will take tan this side, so this would be sec square a minus tan square a, okay, plus again we will take cot square this side is equals to x, right? The value of this is 1 because 1 plus tan square theta is equals to sec square theta, and 1 plus cot square theta is equals to cosec square theta. So this would be nothing but 5 plus 1 is equals to x. So the answer is x is equals to 7. Okay. Let us solve this next question. Okay, we have to prove that LHS is equals to RHS, right? So let's try to simplify LHS. So we need the LHS in terms of sec theta and tan theta, right? So let us divide both numerator and denominator so that the value remains same, numerator and denominator by cos theta, right? So this will give us sin theta by cos theta is tan theta minus 1 plus 1 by cos theta is sec theta divided by, again this would be 1 plus tan theta minus sec theta. Okay, so we can rewrite this as tan theta plus sec theta minus 1 divided by tan theta minus sec theta plus 1, right? Okay, so we know the formula 1 plus tan square theta is equals to sec square theta. So this means 1 is equals to sec square theta minus tan square theta, right? So we will use this formula here. So instead of 1, we'll use this sec square theta minus tan square theta. So this is equals to tan theta plus sec theta minus sec square theta minus tan square theta, right? Divided by same, that is tan theta minus sec theta plus 1, right? So let us simplify this. This would be, let us get rid of this minus. So this would be tan theta plus sec theta plus tan square theta minus sec square theta divided by tan theta minus sec theta plus 1. Okay. So this is in the form of a square minus b square, right? So we know a square minus b square is equals to a plus b into a minus b, right? We'll just expand that. So this is equals to tan theta plus sec theta plus tan theta plus sec theta into tan theta minus sec theta, right? Divided by tan theta minus sec theta plus 1. Okay. So we will take this tan theta plus sec theta as a common in this numerator. So this would be tan theta plus sec theta into 1 plus tan theta minus sec theta divided by tan theta minus sec theta plus 1. So this part in numerator and denominators gets cancelled. So we will get tan theta plus sec theta, right? Okay. This is our LHS. Let us solve the RHS too. So earlier we had LHS is equals to tan theta plus sec theta. So let us try to simplify RHS and let's see if we get the same thing. Given RHS is 1 by sec theta minus tan theta, right? This is equals to, again instead of 1 we will take this as sec square theta minus tan square theta, right? So this is again sec square theta minus tan square theta. Again this is in the form of a minus b. So we can further simplify this as a plus b, that is sec theta plus tan theta into a minus b, that is sec theta minus tan theta, right? So we have the same sec theta minus tan theta in denominator. So this gets cancelled out. So here again we get sec theta plus tan theta is equals to RHS. So LHS is equals to RHS. We proved it, right? Okay. So let's look at this next question. Again, we have to prove LHS is equals to RHS, right? So let's say LHS is equals to cos A plus sin A, right? So we need to get this in terms of cosec A and cot A. So we'll do one thing. We will divide both numerator and denominator by sin A, right? So this gives us cos by sin is cot A, okay, plus sin A by sin A is 1 minus 1 by sin A is cosec A, right? Divided by, so again we get cot A minus 1 plus cosec A. So rearranging this we get cot A minus cosec A plus 1 divided by cot A plus cosec A minus 1. So we know 1 plus cot square theta is equals to cosec square theta. So this implies 1 is equals to cosec square theta minus cot square theta. So we'll just substitute this here. So we'll get cot A minus cosec A plus cosec square theta minus cot square theta. Okay, sorry, cosec square A minus cot square A, okay, divided by cot A plus cosec A minus 1. So this is in the form of a minus b. We can open it up. This will be cot a minus cosec a plus cosec a minus cot a into cosec a plus cot a, right, whole divided by the denominator is cot a plus cosec a minus 1. So we need numerator in terms of this denominator, and we can get it, right, cot a plus cosec. So we'll take this out. We'll take cosec a minus cot a as common. So this would be minus 1 plus cosec a plus cot a, right? The whole is divided by cot a plus cosec a minus 1. So numerator and denominator gets cancelled out. We will get cosec a minus cot a is equals to RHS. So we proved that LHS is equals to RHS, right? Okay. Let's look at this next question. If sin a plus cos a is equals to root 3, then prove that tan a plus cot a is equals to 1. Okay. Let us take left hand side. Let us see what left hand side here is tan a plus cot a, right? So this is the value they have given, and this is what we have to prove, right? Tan a plus cot a is equals to 1. So left LHS of this is tan a plus cot a. Let us take it as tan a plus 1 by tan a, right? This is equals to tan square a plus 1 divided by tan a. So we have an identity, tan square theta plus 1 is equals to sec square theta, right? Sec theta divided by tan a. So let us expand sec. Sec is nothing but 1 by cos square theta, cos square a. So tan is nothing but sin divided by cos. So cos and 1 cos gets cancelled. So the resultant would be 1 by cos a into sin a. Okay. Let us try to simplify this. Sin a plus cos a is equals to root 3, right? So let us square the both sides. Squaring both sides, we get, so sin square a plus cos square a is equals to 1 plus 2 sin a into cos a is equals to 3, right? So let us take 1 this side. So 2 sin a into cos a is equals to 3 minus 1, that is 2. So this implies sin a into cos a is equals to 1, right? Substituting sin a into cos a is equals to 1 in the LHS that we have obtained, this would be 1 divided by 1, so is equals to RHS. Hence proved. Let's look at this next question. So they have given, if 1 plus sin square theta is equals to 3 sin theta into cos theta, then prove that tan theta is equals to 1 or 1 by 2. So let's start with this. So they have given 1 plus sin square theta is equals to 3 sin theta into cos theta, right? So we want tan theta, so we will divide the whole equation by cos theta, okay? Or we will divide the whole equation by cos square theta. So dividing the whole equation by cos square theta, we will get 1 by cos square theta is sec square theta plus tan square theta is equals to 3 tan theta. right? So we know 1 plus tan square theta is equals to sec square theta, right? So we will use this identity here. 1 plus tan square theta plus tan square theta is equals to 3 tan theta, right? So this will be 1 plus 2 tan square theta minus 3 tan theta is equals to 0. So this is nothing but 2 tan square theta minus 3 tan theta plus 1 is equals to 0. So this is in the form of 2x square minus 3x plus 1, right? So we can solve this. So if we solve this, we will get minus 2 into minus 1 is equals to 2, and minus 2 plus minus 1 is equals to minus 3, right? So we will use this. So this is nothing but 2 tan square theta minus 2 tan theta minus tan theta plus 1 is equals to 0. We will take 2 tan theta as common. So this will be tan theta minus 1 into tan theta minus 1 is equals to 0. So this implies 2 tan theta minus 1 into tan theta minus 1 is equals to 0, right? So from here, if we assume 2 tan theta minus 1 is equals to 0, then this gives us tan theta is equals to 1 comes here and 2 comes here. So either this, or so taking this, we have, if tan theta, so taking this, we have tan theta minus 1 is equals to 0, then tan theta is equals to 1, right? So this is what they have asked. So from here we have tan theta is equals to either 1 or 1 by 2, right? Okay. Let's look at this next question. So they are asking to prove LHS is equals to RHS. Let us try to simplify and see. So this would be 1 by cot square A plus 1 by 1 plus tan square A is sec square A, right? So cot square A is nothing but sin square A divided by cos square A, right? Plus sec square A is nothing but cos square A by 1, right? So this would be sin square A plus cos to the power 4A divided by cos square A. So this would be tan square A plus cos square A, right? So again tan we can write it as sin divided by cos. Okay, let this be. So this is our LHS. Let us try to simplify the right hand side too. So RHS is equals to 1 by sin square A is nothing but cos square A minus 1 by cosec square A is nothing but sin square A, right? So this would be 1 minus sin square A into cos square A divided by cos square A. So this comes out to be 1 divided by cos square A is sec square A minus sin square A, right? So sec square A is nothing but 1 plus tan square A, and sin square is nothing but 1 minus cos square A, right? So this would be 1 plus tan square A minus 1 plus cos square A, right? So 1 minus 1 is 0, tan square plus cos square A is RSA, right hand side, right? So we have LHS is equals to RHS. So this is proved. Okay. Let's look at this question. So we have to prove left hand side is equals to right hand side, right? Let's try to simplify left hand side first. So they have given 1 plus cosec A divided by cosec A, right? Let's do one thing. Let us take this everything in terms of sine, right? So 1 plus cosec A divided by cosec A is equals to 1 plus 1 by sine A whole divided by 1 divided by sine A, right? So this would be sine A plus 1 divided by sine A divided by 1 by sine A. So this sine A gets cancelled out, right? So what remains is sine A plus 1. Okay, we can't simplify it further. So let us keep this as our LHS, right? Let's try to simplify our right hand side now. So they have given cos square A divided by 1 minus sine A. So we know cos square A is nothing but 1 minus sine square A, right? So this is equals to 1 minus 1 minus sine square A divided by 1 minus sine A. Yeah, this is in the form of A square minus B square. So this will be A plus B into A minus B divided by 1 minus sine A. So sine A gets cancelled out. So even even in RHS we get 1 plus sine A. So LHS and RHS are same here. So this means we proved the given trigonometric identity, right? Let's look at this next question. So they have given let 2a plus b and a plus 2b be acute angles such that sine 2a plus b is equals to root 3 by 2 and tan a plus 2b is equals to 1. Find the value of cot 4a minus 7b. Okay. So they have given sine 2a plus b is equals to root 3 by 2. We know sine 60 degree is equals to root 3 by 2. So this implies 2a plus b is equals to 60, right? Okay, they have also given that tan a plus 2b is equals to 1 and we know tan 45 degree is equals to 1, right? So this implies a plus 2b is equals to 45, right? So let's keep this equation 2. But actually we need to eliminate either a or b so that we can get the value of other and then we can substitute that. So here it is a plus 2b, but here it is 2a plus b. We'll do one thing, we'll multiply the whole equation by 2. Okay, so then we will get 2a plus 4b is equals to 90. Okay, right. Now we can eliminate actually 2a here. So let's do one thing, we will minus 1 from 3. We'll minus 1 from 3, then we'll get 2a plus 4b is equals to 90 degree minus 2a plus b is equals to 60 degree, right? Okay. So 2a minus 2a is 0, right? 4b minus b is 3b. 90 minus 60 is 30, right? So this implies b is equals to 10. Okay. So if we substitute that here, 2a plus 10 is equals to 60 implies 2a is equals to 60 minus 10 is 50, a is equals to 25 degree, right? So they have asked to find the value of cot 4a minus 7b, and we know a and b, so we'll just substitute them. This is equals to cot 4 into 25 minus 7 into 10, right? This is nothing but 100 minus 70, so they are asking for cos 30 degree, and tan 30 is, let me just draw this. So tan 30 is opposite by adjacent, that is 1 by root 3, and cot 30 would be reciprocal of it, that is nothing but 1 by root 3. So this is our answer, right? Let's look at this next question. So if a sin theta plus b tan theta is equals to m, and b sec theta plus a tan theta is equals to n, prove that a square plus n square is equals to b square plus m square. So they have given m, they have given n, so we need to prove that a square plus n square is equals to b square plus m square, right? So let's do one thing. Let's bring m and n one side and a and b one side. So this would be a square minus b square is equals to m square minus n square, right? We need to prove this, right? So we need m square and n square here to do our operation. So let us square our m. So this would be a sec theta plus b tan theta whole square, right? So this would be a square sec square theta plus b square tan square theta plus 2 ab sec theta tan theta, right? Similarly, n square would be b sec theta plus a tan theta whole square, right? So this would be b sec square theta, sorry, b square sec square theta, a square tan square theta plus 2 ab sec theta tan theta, right? And we need to get m square minus n square, right? So let us minus m square minus n square is equals to plus 2ab sec theta and minus 2ab sec theta gets cancelled out. So what we get is a square sec square theta plus a minus a square tan square theta, right? Plus b square tan square theta, right? Minus b square sec square theta, right? So this is equals to, if we take a square common, so this would be sec square theta minus tan square theta plus, let us take b square common, so b square is nothing but tan square theta minus sec square theta, right? So we know that 1 plus tan square theta is equals to sec square theta, right? So sec square theta minus tan square theta is nothing but 1, right? And tan square theta minus sec square theta is nothing but minus 1. So what we get is a square minus b square. So m square minus n square is equals to, we got this, right? So we can rearrange this as a square plus n square, right, is equals to b square plus m square. So hence proved. Therefore we proved this, right? Let's look at this next question. So they have given the value of x as sin theta plus cos theta, right? And we need to prove that sin to the power 4 plus cos to the power 4 is equals to 2 minus x square. Okay. So here in this we want x square, right? So we'll do one thing. We'll square the whole equation. So this would be sin square theta plus cos square theta plus 2 sin theta into cos theta, right? So sin square theta plus cos square theta is 1. So x square theta is equals to 1 plus 2 sin theta into cos theta, right? So they are asking for x square minus 1, right? So we can get that here. X square minus 1 is equals to 2 sin theta into cos theta, right? So let us substitute this in the left hand side here, right? So this is what we have to prove. So this is, sorry, this is left hand side and this is right hand side, right? So let us take the right hand side and let us substitute that. We know x square minus 1 is equals to 2 sin theta into cos theta, right? So right hand side is equals to 2 minus 2 sin theta into cos theta whole square divided by 2, right? This is nothing but 2 minus 4 sin square theta into cos square theta divided by 2. So this is nothing but 1 minus 2 sin square theta into cos square theta, right? So this is our right hand side. Let us try to simplify the left hand side too. So in left hand side they have given sin to the power 4 theta plus cos to the power 4 theta, right? So this is in the form of a square plus b square. So we know the formula, a plus b whole square is equals to a square plus b square plus 2ab, right? So a square plus b square is equals to a plus b whole square minus 2ab, right? We'll just do that here. We are taking sin square theta as a and cos square theta as b, okay? So this would be nothing but sin square theta plus cos square theta whole square minus 2 sin square theta into cos square theta. And we know that sin square theta plus cos square theta is equals to 1. So this is nothing but 1 minus 2 sin square theta into cos square theta. So we have got the same for LHS and RHS. So this implies LHS is equals to RHS. So hence proved, right? Okay, this is the end of introduction of trigonometry. So I sincerely thank you for watching this, and I hope the concepts in the introduction to trigonometry chapter is clear to you, and I also hope you had good practice. Do let me know in the comments if you found this video useful, or if you have any suggestions like things I need to improve, or if any mistakes I have made. Do like the video if it was helpful. Do subscribe to my channel, that is Studym8 for class 10, and take care. All the best.